Hi everyone, welcome to Caltex Academy. Today on our board we still have integration of odd powers of cosine and sine. In our previous video we looked at video number 1 with power of 3. So if you are curious to see that video, the link is in the description of this video. Go ahead and watch it also and learn something from that video. So before we proceed on, thank you very much for coming into this channel and clicking on this video. If you are new, my name is Julius. In this channel, we handle physical sciences like physics, chemistry, and mathematics. So let's move on and take a look at what to do exactly if you are given odd powers to the power of 3, to the power of 5, 7, 9, and mention them. So the first thing you have to do here, you have to remember the two rules that we already talked about in our first video, where we use the identity of sine square theta plus cos square theta equals to 1. And secondly, we also use u-substitution somewhere in the process of the integration. So with all this said, let us dive into the video. Now, the first thing we have to do is to copy our first question down, and that is A, that says we need to integrate cos to the power of 5 of angle x with respect to x. Now here, we can rewrite this expression in 2, where we have cos of x term is cos to the power of 4 of also x with respect to x. Now secondly, we have to write this cos to the power of 2 as a square. Now in the next step, we have the integral of cos. Let's simply maintain our first cos of x here. Then we split this into 2, where we have cos square x, and perhaps we can create a bracket here, and this bracket should be taking our second cos, but we have to square in order for us to obtain back 4 with respect to x. Now after this, we can rewrite cos square x in terms of sine. So from our identity sine square x plus cos square x, this can be equals to 1, as we know that. So making cos x as the subject to shoot what we have here, we'll have cos square x equals to 1, taking sine square x to this side, we have sine square x from the right hand side, and we can substitute in here. So let's move on in our next step, where we have to maintain the first parameter cos x, and here let's substitute in 1 minus sine square x. So this one is also squared with respect to x. Now after that, the next thing we can do here is to substitute this parameter inside here with u, because when we integrate sine, we can get cosine, exactly the function outside here. And let's go ahead and extract sine x to be equals to u. Now integrating the left hand side with respect to x, we have cos x with respect to x, that is dx here, and the integral of u is 1 with respect to u, making the x the subject. We'll have dx is the same as the u divided by cos of x. Then after that, we can make substitution here, and we have the integral of cosine of x into one minus, so here is u square and also is squared du over cos x. Now since we have cos x from the numerator and cos x from the denominator, we can now cross them out. So let's rewrite the remaining things from here where we have the integral. Now we can open our bracket up here, and we have still 1 minus u square. We close it, and it's also squared, so we say square du. So before we integrate, we need to first expand this, and this is equivalent to the integral of, we can square the first term, and when you square 1, you get 1. So here is 1, and then you multiply 2 times 1 times negative u square. So that amounts to negative 2 u square. Then we square the last term here, it becomes positive u to the power of 4. Now we can close this bracket also with respect to u. So at this stage, we can now go ahead and integrate all these 3 terms here. So the first term integrates to u. Now the second term integrates to 2 over 3 u cubed plus 1 over 5 u to the power of 5 plus our constant. So lastly, we just need to substitute back our u. This implies that when you integrate cosine to the power of 5 of x with respect to x, we will get u is in terms of sine. So we have sine x minus 2/3, also sine, but this time is to power 3. So you can place that to power 3 of x. And the next one is 1 over 5 sine to the power of 5 of the angle x plus our constant of integration. Now this is as simple as it. So the next question here is, we are integrating sine to the power of 5 with angle of 2x with respect to x. So let's go ahead and have this integral here. Let us switch colors to part B, and we say our part B says integrate sine to the power of 5 of 2x with respect to x. So the next thing here is to rewrite, splitting it into 2, where we have sine of 2x, and again we have sine to the power of 4 of 2x with respect to x. Again, splitting this in terms of square, we will have the integral of sine of 2x. Now, it's also a good idea to create a bracket here where we have sine square of the angle 2x is squared with respect to x. Now after this, we can make sine square 2x in terms of cos. So let's have the integral of sine with angle 2x, and inside here this can be in terms of 1 minus cos square 2x, and we can close a bracket here, and we can remember that is also still squared with respect to x. Our cosine of 2x as our angle should be equivalent to u. Therefore, when you differentiate cos, we get negative sign. So using chain rule, we'll have here 2 sine of 2x with respect to x equals to du. Now making the x the subject, we'll have du over negative 2 sine of 2x. So after that, we can move on to make a substitution where we have the integral of sine 2x multiplies our 1 minus, instead of cosine, this time we're using u, because that is what we have given here, and is raised to power of 2. And also instead of the x, we can write this to replace the x as du over negative 2 sine of 2x. So let us go ahead and cross this sign with our sign here. But remember, we have preserved negative 2 as a denominator, so we can factor it out as 1/2 but negative integral of. So here we can open up this bracket by expanding. So we also use our shortcut where we have 1 minus 2 u square plus u to the power of 4. So our integration is with respect to u. So let's go ahead and do the integration. And again, we can maintain our negative 2 here. That will multiply all the results of integrating those terms inside. So integrating 1 with respect to u, we get u. And integrating 2, u square, we get negative 2 over 3 u cubed, since we increase this by 1 and we divide by the new power. Now next we'll have here 1 over 5 u to the 5th power, and we can close our bracket here plus our constant of integration. So we're left with substitution and opening up the bracket. So our negative 1/2 will multiply u, and u is cos 2x. So the first term here becomes cos 2x minus 2 over 3, also cos to the power of 3 of 2x. Now the next one is plus 1 over 5 cos to the power of 5 of 2x. So we also close our bracket and we add the constant of integration. Now lastly, we just need to open up the bracket, and remember it was integration of sine to the 5th power of 2x. So when you multiply 1/2 negative with the first term, we'll have negative 1/2 cos of 2x. So we also multiply this, negative and negative goes to positive. Now these two will cancel that, we shall have 1/3, also cosine to the power of 3 of 2x. Now we multiply negative and positive, it goes to negative, so we have there 1 over 10 cosine to the power of 5 of 2x. And finally, we add our constant of integration plus c. So that becomes the result of this integration. So thank you very much for watching up to this time. If you enjoyed the video, go ahead and subscribe to the channel, like the video and share, such that this video will go viral. See you in the next video where we shall look at power 7. Peace out.